Hello, my name is Aaron. This is for EEE 120, Lab 3. I'm going to be going over what we tried to accomplish in this lab. The first logic circuit that we went ahead and created was the 4-bit registry. The way that this circuit operates, we have a D value. We can go ahead and put in, let's say, 5. We can enable it through our 4-bit mux. So it's taking in option B. And we can go ahead and do a clock cycle. And then that value will be stored at Q. Q is then routed back into the 4-bit mux to A and is sent back through the um, asynchronous flip-flops. There's one for each bit, and it just keeps passing it through to itself until we go ahead and let's say we want to put in another value, 7. So it'll just keep sending that value to itself to keep that in that value stored. The next circuit that we created was the program RAM. We utilized one of Digital's default circuits, which is, I believe, a RAM separated ports. Yep. And the way that this operates, we have an address value, we have a data in value, we have a write, and we have a clock signal. So if we go ahead and set the address to 5, we have a value of 0 at address 5. And then let's say we want to put in a value of 6. We can select write, send a clock signal, and then we're holding that value of 6 at the memory address 5. And then the final circuit that we created was the brainless CPU. Obviously, the circuit is a lot more complicated than the last two. It's got many functions. So in this design, we're utilizing the ALU that we created earlier. Right there. There's the ALU circuit. We also have the 4-bit registry that I just showed. And we have two 4-bit muxes that we designed earlier. One of the muxes is for the accumulation value, and one is for the data value. And we also have the program RAM that I just showed. So let's try to test some of the functionality of the brainless CPU. One of the things that we can do is through the ALU, we can load the accumulator with a value. So if we set our data into 2, we can see that the output of the ALU will be 2. And since we have load accumulator selected, we should get a 2 at the accumulator. So if we cycle the clock signal, there you go, we got a 2. Now, let's try to load something into memory, which is the data bus output. Um, First, before we try to load it, we'll go ahead and read it to make sure there's nothing there. So we select read, and we'll put this to 0, and we'll select an address. We'll say 5 again. So we're registering a value of 0 at address 5. Now all we want to do is we want to load the data bus from the accumulator. And we want to select write. And that should be it. We go ahead and we cycle the clock. Then we deselect those, go to read. And yep, at address 5, we held the value of 2. And we can also, if we select write, we can go ahead and let's see, reset that value. And we go back to read. Oh, it's still 2. Let's see. Write. Ah, clock signal. Read. and then we reset the value of the data bus. But there's many other functionalities of the brainless CPU. We can do addition, subtraction with our ALU. We can store up to 15 values on our data bus. Yeah. Oh, excuse me, 16 values. But yeah, that's pretty much the basics of the circuit and how it works. Thanks for watching.